Chapter 1 is all about the vocabulary of statistics. And in this first section, we are specifically talking about the big idea of statistics and then a couple really important terms. In this video, I'm going to hit the highlights, but you definitely want to spend some time going through the notes and resources provided on Blackboard to make sure you get the complete picture of what's going on in Chapter 1, Section 1 of our book. So the big process for statistics is that we have a question we want to answer. And in this first chapter, and a little bit in chapter 2, but mainly chapter 1, we're going to be talking about the preparation phase of doing a statistical study, where we've got to decide what is it we're actually trying to answer, what big question, and then where can we get good data, and how can we get good data to get the answers to the question that we're looking for. And we'll see in later sections that trying to decide how to get data is probably the hardest part, but the most important part of a statistical study, because if you have bad data, all of your analysis and all of the hard work on that data is completely for nothing because it's bad data and the results are not reliable. So we'll talk about the preparation in the rest of Unit 1, or in the rest of Chapter 1. And then we're going to move on to analyzing the data, which is going to be the bulk of Chapter 2, where we're going to look at all this raw data and try to condense it and organize it in a way that we can understand it relatively clearly. It's overwhelming to look at a giant data set of 100 or even 1,000 points, but maybe we can make a chart or make a graph or make a couple different types of graphs that will help us figure out what this data is telling us. And then once we get to Unit 2 through the end of the course, we're going to be looking at how do we make inferences from the data? How do we make the decisions based on what the data is telling us? And this is where statistics gets a lot of fun, and there's a lot of intricacies to analyzing and interpreting data in a way that is honest and fair and transparent. So we'll talk about all of those points as we get further into the course. So today what I want us to do is really talk about the two big terms from this first section, and that is what is a population and what is a sample. So a population is defined to be everybody or everything that we could possibly collect data from. For example, at Wake Tech, the population would be all of the students taking classes in any given semester. Typically at Wake Tech, we have about 30,000 students per semester. And there is no way you could go around and ask every single student, all 30,000 students, a question and get data from all of them. It's too many students, they're spread out all over the globe, and it really is impossible. You would have to have access to DataTel, which is our student information database, to get information about all the students if you really wanted to find out something about them. So say you wanted to know the average age of a Wake Tech student, if you had access to DataTel, which I don't, you have to be cooler than me to have access, you could go into DataTel and get a list of everybody's birthdays and calculate everybody's age and then come up with the average age of all 30,000 students. But again, there's no way that you or I could go around and ask every single student for their age. It's too many, it's too overwhelming. There's no way we could do it. So what we generally do is we generally talk about samples. And samples are a small subset of the population, and we hope that we get a good sample where whatever data comes from that sample is pretty representative of the whole population. So for example, I can't talk to all Wake Tech students, but I could collect everyone in this class's age. We could create some type of survey or discussion board on Blackboard where everyone put in how old they were, and then from there we could get the average age of the students in this class. And I bet the average age of students in this class is pretty representative of all of Wake Tech. So say the average age of all of y'all was about 22, we could probably conclude that the average age of all Wake Tech students is around 22. And we'll see as we go forward that when we're studying samples, we do give ourselves a little bit of a buffer. Just because our sample had an average of exactly 22, we don't want to claim that that's the exact population's age, but we think it's probably somewhere in that neighborhood. So we think it's around where the sample is because we know a sample is not an exact match to the population, but we hope it is